present our presentation on the topic of beta-oxidation of fatty acid and energetic. Now my groupmates will introduce by themselves.
My name is Sanjana Viswas from BMLT second year.
My name is Shumidamna Bhumik from BMLT second year.
My name is Pratap Chakraborty from BMLT second year.
So here we go. First of all, we know about what is beta-oxidation of fatty acid. The breakdown of fatty acid to acetyl-CoA. It occurs in mitochondria and it is basically an aerobic process. After production of acetyl-CoA is fed directly into the Krebs cycles. It occurs in many tissues, includes liver, kidney and heart. Beta-oxidation of fatty acid involves three stages. First one is activation of fatty acid. Second one is transport of activated fatty acid. And the last one is proper beta-oxidation. Now Sanjana will explain the next part.
So now I will discuss about the beta-oxidation of fatty acid and energy generated by the beta-oxidation pathway. So as we all know that beta-oxidation required for some reproductive steps. In these steps required for fatty acid molecule which is generally present in cytoplasm and it transferred to the mitochondria. Because of beta-oxidation occurred into the mitochondria. The step of beta-oxidation is transfer of activated of Fa. So the fatty acid will activate it into the fatty acid-CoA with the enzyme of thiokinase. So the name suggests of thiokinase, that means it is related to the energy, and thiokinase will utilize the ATP and it will form AMP plus pyrophosphate. So two high energy bonds are utilized so that the fatty acid-CoA which has been present in cytoplasm, it cannot traverse the mitochondria. So that's why the function will be carried out the carnitine. Carnitine is the one of the tripeptide. Carnitine will form the fatty acid carnitine with the help of the CAP, which is carnitine acid transferase 1. And carnitine acid is means that the carnitine into the acyl group with the help of the enzyme CAP1, which is carnitine acyl transferase 1. Now the fatty acid carnitine will able to cross the mitochondrial membrane with the help of the transcriptase, which is generally present in the mitochondria. So that's why the function will be carried out the carnitine. Carnitine is the one of the tripeptide. Carnitine will form the fatty acid carnitine with the help of the CAP, which is carnitine acid transferase 1. And carnitine acid is means that the carnitine into the acyl group with the help of the enzyme CAP1, which is carnitine acyl transferase 1. Now the fatty acid carnitine will able to cross the mitochondrial membrane with the help of the transcriptase, which is generally present in the mitochondria. Fatty acid carnitine is inside the mitochondria and it reconverted into the fatty acid-CoA. And it will finally reach into the mitochondria and it entered to the beta-oxidation with the help of the enzyme CAD2, which is carnitine acid transferase 2, and with the help of CoA. And carnitine will released and it will back to the cytoplasm for binding more molecule of fatty acid-CoA. So this is how the preparation of beta-oxidation will occur. Then now I will hand over to Dimi to explain the next one.
Thank you, Sanjana. So as we have seen that there are three stages in this reaction. Now I will explain the third stage and its reaction. So let's start the third stage, proper beta-oxidation. There are four steps: oxidation, hydration, oxidation and cleavage. Now oxidation, SL-CoA undergoes dehydrogenation by FAD-dependent flavoenzyme. Here SL-CoA dehydrogenase convert into trans-enol-CoA. Now in hydration, trans-enol-CoA convert into beta-hydroxy SL-CoA with the help of enol-CoA hydratase enzyme. Now next part we will discuss by Pratap.
Thank you, Dimi. Now the fourth reaction is oxidation. Beta hydroxy SF2A dehydrogenase catalyzes the second oxidation of generic NADH by remaining 2H atom beta hydroxy SF2A and coenzyme NAD plus it form beta keto SF2A. Now the final reaction in oxidation, the liberation of two carbon fragment, liberation of two carbon fragment, acetyl-CoA from SF2A. These occurs by a catalase. These occurs by a thallitic ligase catalase, the beta keto SF2A catalase.
When we talk about the palmitic acid, that is a system of compound which will degrade with the help of Alice enzyme and produce two major common compound, that is acetyl-CoA and acyl-CoA, which is two partner less than the parent compound. And again, this two partner less compound that are produced in this process at the end of the cycle, and the food steps that is usually occur. After that, the whole cycle was occur 7 times. Now we will discuss about the analytics of beta-oxidation. As we already seen that in the first preparatory step, that is the activation of acetyl-CoA, two high energy bond was utilized. That is, two ATPs were utilized in that reaction. After that, in the cycle, one FADH2 will produce, which will liberate two ATPs, and one NADH will produce, which will liberate three ATPs. At last, one acetyl-CoA will enter into the TCA cycle and produce 12 ATPs. The whole cycle was occurs 7 times. Then the total number of FADH2 is 7. That is, that 7 FADH2 will produce 14 ATP. And the total number of NADH is 7, and that 7 NADH will produce 21 ATP. And the total number of acetyl-CoA is 8, and that 8 acetyl-CoA will produce 96 ATP. In total, the ATP is 131 ATP. But as we know, as we already learned that in the preparatory step, there is a utilization of 2 ATP. So the net energy, that is ATP, is 129. Thank you.